Okay, very good. So we are in for lesson 7. We are saying parallel, perpendicular, and skew lines. Now you all know what parallel lines are. You see that parallel lines are lines which do not meet in that order. Then perpendicular lines are angles and lines which make an angle of 90 degrees. Sometimes they don't use the word perpendicular, they can use the word right. The lines which are at right angles, or the lines which are normal. Instead of the word perpendicular, you can use the word right normal in the vector language. So we have parallel lines which do not meet. Then you have perpendicular, which are 90 degrees. Then if two lines meet at a point, if you have any two lines which are not parallel or not perpendicular, then those ones we call them skew lines. We call them skew lines. So if you know the conditions how to prove for parallel vectors, because parallel vectors, we say that once you cross the two parallel vectors, you get a zero. Remember that in lesson 2. Cross two parallel vectors, you get a zero. Dot two perpendicular vectors, you get a zero. Take note of that. All right, good. So we go on. Now, when you test for parallel vectors and perpendicular vectors and it fails, then you conclude that it is a skew line. Okay, good. An example, or we are saying, consider lines R1 and R2. If R1 and R2 are skew lines, it means they are not parallel and they are also not perpendicular. Yes, they can say that prove that the two lines are skew lines. What you do, you go by dotting them. If you dot and you get a zero, you say they are not skew lines. Or if you cross and you get a zero, you say they are not skew lines. But if you dot and you get you don't get a zero, then you also cross and you don't get a zero, then you conclusively say they are skew lines. Examples show that line is x minus 1 over 2 equals to y plus 3 over 1, z minus 4 over 4, and x over 3, y minus 2 over negative 2 is equal to z over negative 1 are perpendicular. They want us to prove that those two lines are perpendicular. Okay, shall say. Solution. Now, here, what we do, perpendicular, we're going to dot them to say that they give us a zero. But here, we shall say only pick denominators. Only pick denominators. They are those who work in this science here. And the denominators here we can have mu1 and we can have mu2. Now, what is our mu1? Okay, let's see. What is our mu1 and mu2? So, mu1 is, we shall get it there, and mu2 is, we shall also get it there. Mu1 is denominator in line 1. Where is line 1? This is my line 1. Denominator here. Denominator, I'll pick this, that. That will give me my mu1. That is a 2, a 1, and a 4. Then mu2 will be from 3, negative 2, and a negative 1. You can see that. Please, to prove whether it's perpendicular, you only deal with the parallel vectors or the denominators only. Then the rest is just a story. So now we shall now say that u1 dot u2, it must give us a 0 if indeed they are perpendicular lines. So now we shall say a 2, 1, 4 dot, okay, dot a 3, negative 2, 1, negative. Okay, this will give us what? A 2 times 3 will be a 6 plus 1 times negative 2 will be a negative 2 plus 4 times negative 1 will be a negative 4. You see that this one here is equal to 0. You can say hence the line is perpendicular. We revised those conditions back then. You can view in the playlist. You can view in the playlist and see where we did that work to show that the two lines are perpendicular. This has been our example 1. Let's now see example 2 and what they will be telling us. All right, good. So we are in for another example. They're saying that show that the line is R is equal to that, and the line this are parallel. Now we know that for parallel vectors, they must, if you factorize a certain number, you get a common factor in them. So now this will be, all right. So, but still here, we also pay attention to the denominators. Now what's the denominator here? Now here, the denominator is the coefficient of this lambda. So this will be 1, 2, negative 1. You all know that. Then the other one is negative 3. Please, we learned how to do this. You can go and view the videos in the playlist. So you have that. Now, when you factorize, For parallel, factorize. So for parallel, the simplest way is factorize. Factorize to say common factor. And now you realize that what happens here is you can also cross, but crossing may waste our time. So I will say that u1 is also equal to u2. That's what I want to do. Now u1 is 1, 2, negative 1 equals to negative 3, negative 6, 3. Very good. Is there a common factor anywhere? 2, negative 1. Is there a common factor anywhere? Common factor is negative 3. Out. Okay. Negative 3 divided by 3 will be a 1. Negative 6 divided by negative 3 will be a 2. Rather 3 divided by negative 3 will be a negative 1. Now I think that these ones here are the same, and we have this. So therefore, we shall say that u1 is equal to 3 over mu2. Hence they are parallel lines. Hence they are parallel lines. As simple as that. All right, so let us proceed. Let us proceed with, they are saying, angle between two lines. Angle between two lines, now we shall say, consider line R1 is equal to A plus, this is A1, this is A1, A2. Is equal to A1 plus lambda mu1. R2 is equal to A2 plus lambda mu2. Now, to find the angle between two lines, we pay attention to their parallel vectors, the parallel vectors. Okay. Now, angle between two lines given by mu1, its formula is given by that. Mu1 dot mu2 is equal to magnitude of mu1. So we just dot the magnitude of mu1 times magnitude of mu2, a cos of theta. Now that's what we want. Now examples, they're saying find the angle between this. All we need is the mu, the denominators, and the mu are denominators. So solution. So mu1 is equal to the denominators are the ones we want. Then mu2 is equal to, we want denominators like that. So where are you? Mu1, 3, 2, 1, 3, 2, 3, 1, 2, 3, 1, 2. It is there. Here, denominator is the coefficient of this one's here. So this will be 4, negative 5, and negative 1. Finished. Now what we need from this, we know that mu1 dot mu2, then we get that. So it will be from mu1 dot mu2, it will be equal to magnitude of mu1, magnitude of mu2, a cos of theta. So let's substitute in the values, and what are we going to have here? So now this will be a 3, 1, and 2 dot a 4, negative 5, negative 1 is equal to, the magnitude of this will be bracket square root of 3 squared plus 1 squared plus 2 squared dot all times magnitude of mu2 will be 4 squared plus negative 5 but squared plus a negative 1 but squared. All right, everything cos of theta. Please, you can handle this at a go. Get magnitude of this, magnitude of that, dotting, then you bring a substitute. I'm preferring the method of going direct. So 3 times 4 is 12. Okay, this is negative 5. So 1 times 5 will be negative 5 minus 2 will give us, so you shall have a square root of 3 squared, this is 10, 14 times square root of 4 squared is 16 plus 25, 25 will be 1, so that will be 41, 41 plus that will be 42, a cos of theta. Now here when you make each and everything in the proper order, you see that divided by square root of 14 times the square root of 42. Also decide divide by square root of 14 times the square root of 42. Okay, this goes out with that. Then you remain with a cos of theta is equal to 12 minus 5 minus that will give us 8 over square root of 14 times 42, by the way. So that implies that theta alone will be equal to a cos inverse of 8 over square root 14 times 42. So theta alone will be to 1 decimal place. What will be theta to 1 decimal place? So our theta will be, if you square there, our theta will be 78.1. Our theta will be 78.1 degrees, as simple as that. I will only do one example there because they all mean the same. What you need to get is the mu, and mu comes from the denominators. All right. All right, good. So let's proceed. We have yet another example. Intersection between two lines. Intersection between two lines. Say, given the line, given R1 is equal to A1 plus lambda mu1, and R2 is equal to, this is alpha. It is alpha mu2 intersect if R1 is equal to R2. So a point of intersection between two lines, you equate the two lines. You equate R1 is equal to R2. Then from there you solve and you get the value of lambda. Then the point of intersection is always the same for all of them. So at that point of intersection, x, y, at that point, the meaning here, the point of intersection, the x, y, and the z values of the two lines are equal. So examples, find the point of intersection between the following lines. We have this. So solution, just come and say, solution. Point of intersection between two lines, yes, R1 is equal to R2. So R1 is equal to R2. Now what is our R1? Our R1 is this part. This part here, it is 1 negative 2, 3, plus lambda 2, 1, negative 1 is equal to R2, is this one, negative 1, 3, 7, plus alpha. Now here they change a reason that there are two different lines. That's why they are changing. So negative 2, 1, 2. Now after doing that, you must now generate equations which we will later come and solve. Now the equations, I'll pick them from here. So you have 1 plus 2 lambda equals to, okay, negative 1 minus 2 alpha. You can see that for up. Here I have negative 2 plus lambda is equal to, okay, 3 plus alpha, okay, 3 minus lambda 1, lambda minus negative 1 equals to 7 plus 2 alpha. Now I harmonize them very well. I want the unknowns to be on one side. This to come this side and the one comes this side. So I now come and say from here, I'll have it that 2 lambda. Now when this one crosses the equal sign to come this side to be plus 2 alpha will be equal to, now when this one is coming this side, this one is going to the other side, so it will be equal to negative 2. That is equation number 1. I'm harmonizing this. Have there alpha minus lambda is equal to a 3. Okay? This goes the other side to give us a 5. Please, what I'm doing here is the alpha is coming this side and the 2 crosses. Okay. Last we have this. Okay. I have now negative lambda minus 2 alpha is equal to, this one is going the other side, so it will give us a 4. Why? A 3 crossing the equal sign to become a negative to give us a 4 there. So now this one here is our equation number 2, our equation number 3. They're like that. So we need to solve them simultaneously. Solving simultaneously, and we see the way forward. So here, what I'm going to begin with, I will solve equation 1 and y. These ones have similar values, equation 1 and equation 3. The ones I'm solving. And here I have 2 lambda plus 2 alpha is equal to negative 2. You pick easiest equations. It's all about you. Me, have picked those ones. So, right. So this will be negative lambda minus 2 lambda is equal to 4. Right. And here to get the answer, I will just add. Why am I adding? 2 alpha minus 2 alpha will give me 0. So 2 lambda minus plus negative lambda will give me lambda is equal to, this will give me a 0. Now 2 negative 2 plus 4 will just give me 2. So my lambda is equal to 2. My lambda is equal to 2. And if my lambda is equal to 2, what will I do? I will say using equation 1. So using this equation here, I want to use the simplest. I want to use equation 2. Using equation 2, okay, whereby I have that lambda minus alpha gives us a 5. I'm using equation 2. I'm using equation 2. So it will be now, lambda is what? Lambda is 2. So 2 minus alpha will give us a 5, like that. So what shall we get in the long run? So this will now be negative alpha is equal to 5 minus 2. So negative alpha is equal to 3. Therefore, when we divide both sides, we get that alpha is equal to negative 3. So I have the value of alpha and the value of lambda. Now, we have finished that. Now let's get point of intersection. Point of intersection. Point of intersection, where shall we get it from? Point of intersection. You can choose to substitute in only one side, only. So you can choose this, 1 plus 2 lambda, because you have this, 1 plus 2 lambda, then you have this, negative 2 plus lambda, then you also have 3 minus lambda. To get this can give you the answer. This can give you the answer. Why I'm using this? Because it is this part here. This part. You see that 1 plus 2 lambda is this one. Negative 2 plus lambda is this one. 3 minus lambda is this one. So it will mean that you shall say 1 plus 2 into 2. Okay. Negative 2 plus 2. 3 minus 2. Okay. What will be the point of intersection? Up there I'm seeing a 5. Here I'm seeing a 0. Here I'm seeing a 1. So the point of intersection is 5, 0, 1. That is our point of intersection. All right. As simple as that.